All right, good morning. Welcome to this second training session about eNod4. Yesterday we have had the first session about eNod4-D. I will be your host for today. My name is David Deplanche. I've been working with SCAIME since 2007, so almost 15 years now. And I will be with my colleague and friend, Mr. Desrumeaux. Would you like to introduce yourself, Bernard?
Yes, yeah? I'm an engineer at the customer support service and still at SCAIME from 1990.
Yeah,
and,
right. I was still at school at the time.
Yes, okay. So it's a long time, and I follow my knowledge about SCAIME products is comfortable
for many years, hopefully. We have today also a third colleague, which is Vincent Crémier. He will be dealing with all the technical aspects of the presentation, and Vincent will be able to interact with you through the question and reply or discussion, the chat that you find in the Zoom bar. If you have any problem to hear us or to see us, you can directly discuss with Vincent, and he will help you through the technical aspects. So about the rules of the presentations, let's say, we will, all the microphones are off for this session, so you cannot directly interact verbally with us, but you can, as I said, discuss through the discussion or the question and reply items that you find at the bottom of the page. So you just ask a question, and then you can type it, and we will get it from Vincent, and then we will answer your question later on through the presentation. So today we are speaking about eNod and eNod4-D, which is the dosing firmware. We have a focus on this training session. So I will be myself starting with some general presentation about eNod4 and the range, for those of you who don't know exactly what an eNod4 is for the moment. And then Bernard will be starting the training itself, which is more like a quick start guide, quick start training to help you start with eNod4-D in this case. Right, so about eNod4-D. eNod4-D is of course a digital weighing conditioner, which is developed fully by SCAIME through our R&D team. Not only it's the hardware, but of course the most important with eNod4-D is the flexibility with the different firmwares, meaning that depending on which application you have with your equipment, you have one dedicated firmware with one type of eNod4. So here we have, for example, what is a full production chain in a factory, let's say. Let's take example of a flour production plant for bread. So you have the big silo where you would have the wheat, basically, which is monitored by an eNod4-T transmitter because it's a static application. There is no dynamic thing happening on a silo, it's rather static. Then you have the material supply through the process, which is the eNod4-B, which stands for belt weighing. So this will feed the process from the silo to the rest of the plant. Same philosophy, but in continuous feeding is the eNod4-F for feeding. Try to make it easy to remember. So T transmitter, B belt, F feeding. This will be, for example, for an application where you have an auger, where you have a screw, and then you need to feed your process on a continuous basis, and also handle the refilling of the hopper, which is above the screw. So eNod4-F, and then we end up with what we are speaking about today, which is the eNod4-D, with two different type of applications. The batch mixing, so that means you are dosing from small hoppers into a main hopper where you would be mixing the product afterwards. So eNod will be managing the feeding of this main hopper. Also the batch filling. So for example, you need to fill in some bottle of mustard or ketchup. Of course, it's difficult to feed some viscosity product with volume. So we go to the gravimetric mode, and this is where eNod4 and load cells are used when you need to do some filling process with viscose product. And at the end of the factory, once your let's say your floor is dosed into small packets, then you put it in boxes, and then we have this eNod4-C, which is a checkweigher firmware, where in this case you have a high-speed sorting, high-speed checkweighing features. So as you can see, a full range eNod4 one platform. You will see with Bernard one developing programming environment, eNodView, and then flexibility with different firmwares depending on your application. Little focus about eNod4. So it's a flexible. It offers a flexible communication in the sense that we can address almost 95% of the industrial PLCs, field buses, and protocols that you find in the market. So here we have some of the example: Modbus RTU or Modbus TCP, CAN Open, which is more in the Schneider Electric world, for example. Profibus and Profinet, which is more in the Siemens, or exclusively, I should say, in the Siemens PLC world. Ethernet IP, Ethercat, and some other protocols or field buses are currently under development at SCAIME. But with all these examples here, we already cover 95% of what we find in the industries. Excuse me. eNod4 is also a very useful analysis tool for your weighing chains, weighing systems. So of course we have the configuration which goes through the eNodView 2 software, which comes free of charge with any eNod. You can actually download it from the website already. And you can have not only a diagnosis of the weighing system, but also the incident breakdown detection, which goes either through the eNodView 2 software, the web server, which is, we will detail this a bit later on, the web server being an access to the eNod through a web browser. And pretty new but very interesting is the eNod app, which is a Bluetooth application to connect, or smartphone application to connect via Bluetooth to your eNod4. So with all these tools, you can have a very quick parametering and diagnosis of your weighing system, but we will see that together with Bernard later. We try to make it as easy as possible in terms of implementation. So meaning that we have, well, many ways of doing it, but we also offer some configured HMIs, which is our eNod Touch, which you see here in a small picture. And we also offer some very useful tools, which are libraries, PLC libraries, which means that we have already constructed the mapping of all automation addresses that you can inject directly into your PLC, so that you don't have to redo all the addressing of the to connect with your eNod4. So this means we can offer it mostly in the Schneider Electric, Rockwell, and Siemens with the TIA portal. So you just upload this file, which you can find also on our website, to your PLC, and then you will have a direct configuration through your PLC of the eNod4. So we try to make your life easier in terms of implementation. And once again, the powerful application firmwares, in which case today we are focusing on the eNod4-D for the dosing and feeding process. Here you find a mapping of all the options and possibilities you have, depending on which firmware you select. So let's concentrate on the dosing. So you see all the boxes are ticked green. So the advantage with eNod4-D is that you can connect on all protocols or all field buses. You have all options, including the analog output and the Bluetooth, which I mentioned earlier. And very interesting also is the fact that you can build eNod4-D into a legal for trade approved system through the R61 certification. You could see that some red crosses are still there, but of course you cannot. The reason mostly is that you cannot communicate with a web server on an eNod which doesn't offer any Ethernet bus. So this is why it's red here. And legal for trade certification for the belt or the feeding eNod4 is almost not existing or not needed. So this is why you have those 4 red crosses here. Don't worry, you will get this information into the presentation we will supply to you after this presentation. So you can go back to it and check all the features. Here we are presenting a typical architecture in a company. So let's remain with our flour plant, manufacturing plant. So you have the main PLC, which could be Schneider, Siemens, Rockwell, whatever you have at your clients or what you want to use. We have, as I said, the silo weighing, static weighing monitored through the eNod4-D transmitter and the eNod touch SCAIME HMI. So you see the load cell, the junction box, the eNod4 connected directly to the HMI for local display and parametering of the scale, tearing, zeroing, filtering, whatever you want to do.
Level purpose.
Many purpose, exactly. Then we have the main hopper where we would, for example, dose into a big bag or so emptying or feeding a big bag, for example, with the floor. Or a second hopper, which are both linked to the eNod4-D, the one we see today, which will do the batch dosing of the flour into small packets, for example. And once again, at the end of the process, the eNod4-C monitoring the check weigher and checking that the product quantity in the boxes is correct. If it's not correct, the check weigher ejects the box, and you can then be sure that the boxes are all filled with the quantity that you targeted. So very typical architecture, just one example here. Of course, you can have many more hoppers, advantage being that all eNod4 are on the same bus linked directly to the main PLC, and the PLC subcontracts those tasks, that is to say level monitoring, dosing functions, or sorting to the eNod. The eNod will monitor this application by itself. About eNod-U2 now, so eNod-U2 is not only gives you the possibility to display the weights in real time on your PC, for example. So that's more like during the configuration phases. The eNod4 is having a USB port, which you can directly connect. So no need of any converter. You directly connect to the PC. As I said before, it's a very powerful analysis tool. So usually our clients are using also eNod-View to check the mechanics of their hopper, of their check weigher through some frequency analysis. So it is integrated into eNod-View 2, the FTT analysis. You make an acquisition of the raw signal, and then you check what is the phenomenon of the rolls if you have a conveyor. And you can then implement some strong digital filtering, which we will see with Bernard later on, to eliminate the noise and have the filtered signal as best as possible. Once you have this signal, that if the signal is clearly filtered, then your global accuracy of your machine, of your equipment, is improved. And this is really important to use eNod-View 2 as a not only programming tool, but also kind of development analysis tool. And of course, eNod-View offers all the possibility, which we will see later, about the configuration, calibration, tearing, etc. So we will see that with Bernard. The two last slides I wanted to present to you is this possibility to connect on the eNod4 in the Ethernet version, so through the RG45 port. You directly type in your web browser. It could be Chrome, whatever, Firefox, Internet Explorer. You directly type the IP address of your eNod4. And through, of course, with the password, protected by a password, through this window, you will have direct access to the what's happening on your silo, on your hopper, through your PC. And you can also interact with your equipment from your PC, meaning that you can zero it. You can of course tear it. You can have access to all the filtering features.
All the functionalities.
All the functionalities are also open through the web server. The idea here is that you have installed, let's say, a hopper with eNod4-D at one of your clients, and then your client calls you, my machine is not having a normal behavior. If he gives you the access through the VPN of his company to the eNod, so he gives you the logins, then you can directly see 500, 1,000 kilometers away this screen and interact with the silo hopper on a remote principle. So that means you can at least check if the configuration is still okay, or maybe the client has played a little bit with the parameters. You can also kind of reload or reset some parameters without having to move away to the factory. Of course, sometimes it's also needed to come on site, but this can be a very first check phase to confirm that the eNod is still functioning correctly. And finally, the eNod app application, smartphone application, which is so the Bluetooth board on the eNod4 is a 4.2 Bluetooth generation, and that gives you also the possibility, like the web server. So if you are at the foot of your silo, to connect to the eNod and interact as if you would have an indicator in your pocket. We all have a smartphone in our pockets, so now it's very convenient to be able to connect directly to your equipment at what is the max, maybe 20, 30 meters away from it, without having to plug your PC or plug an indicator. So you can do that through the eNod app from your smartphone. Of course, it's secured by password because we don't want everybody to be able to interact with the equipment. You can do everything that we will show you now, calibration, configuration, some analysis, and also checks to cross-check that the silo is still, or the hopper is still functioning correctly. So to sum up on this first part, you have understood we have one platform, which is eNod4. We have one configuration software, which is eNodView 2. Then multiple ways to go to the eNod4 web server, app, HMI. And 5 different firmwares, depending on which application you will be implementing, either at your plant or at your client's location. Thank you for your attention. So I'm now leaving Bernard start the training by itself. So once again, it's a quick start guide. So we will be having a general introduction to the eNodView software, most of it. This training is meant to, well, we have secured 1.5 hours, but it's really depending on the time of your questions. So don't hesitate to ask questions along the presentation, along the way. And
okay,
Bernard, please start.
Thank you, David, and I will start to explain a little bit the aim of the training about eNod4 and especially eNod4-D. First of all, the connection to our module using the system. Of course, we have a solution for filling and unloading in batch, because
there is two modes.
Two modes that you can select, filling or unloading. Okay. Of course, this system allows high-speed systems, especially for liquids, normally for powder or other system. Generally much more slow when you empty a big bag. The requirements are not the same. Of course, the system can work in a standalone mode or connected to a PLC that has the general control of the system. Okay.
So you are saying that with an eNod Touch, eNod4 and load cells, of course,
yes,
you can already build a rather simple dosing application.
Yes, of course, totally. Because if you have the HMI, you can have the complete instrument inside. Yeah. Okay, a very simple one. Mm-hmm. Also, with eNod, if you have no HMI connected, you can simulate totally the cycle with the system, mm-hmm. and you can adjust the parameters, the settings, the delays, all the functioning can be simulated through eNod. Okay. Okay. So you have here a little display of what we can do with this product. Okay.
So here we have, just going back, so they're not, so it's a mono-product application. So, yes. So here we could imagine a sugar, flour, chocolate, whatever, and each hopper will dose what separately what the PLC instruct eNod4-D. So in this case, we would have as many eNods as we have hoppers.
Okay, and we weigh in cumulative.
Cumulative. So
okay, in a cumulative way. Mm-hmm.
Here is the direct filling of mustard or whatever.
Or everything you want in a container. Okay.
A small container.
Okay.
And here is by unloading.
You have an intermediate hopper that allow to prepare the dose, mm-hmm. then that you
eject into the pot.
Yes.
Okay. Yes.
Okay. Mm-hmm. Example of dosing solution. Mm-hmm. Here you have a simple system that you fill some powder okay. inside the product, because you have the weighing part on the lowing part.
Yeah.
And
so let me start it again.
Yes.
Because it was fast.
Yes.
eNod is fast, but the video is fast.
Yes.
As well.
Okay.
So we see that so there is a target weight, and the scale is below the.
Yes. Okay. You have the scale receptor.
The scale is here basically.
Yes. Okay. Yes. In this case. Okay.
And so just going back on that. So that means here you program the target dose.
Yes. And the in-flight, and automatically there is an in-flight correction.
And eNod does the full batch at once.
Yes.
Okay. Right.
Okay, but there is a tarring because as it is a glass container, mm-hmm. The way of the glass can differ from one glass to the other. So it's necessary to dose in net.
So each start of cycle you have one tear.
Yes, systematically. Okay.
Another example.
Another example. Here it's the quantity of oil or sausage that you put in
fish cans.
Fish cans, yes, mm-hmm. Okay, and it is done automatically because there is a determination of weight in the.
I just wanted to show something. So to be both. So here we have empty cans. Here we see the sauce is
yes.
Isn't it?
Because the incoming recipient is weight and the dose for the complement of sauce.
Of sauce, yeah. So each head has one eNod and one load cell.
Yes.
Okay. And the sauce is basically here and goes through the valve and dose each time.
Okay.
So just to start again, it's a rather high-speed application. Was it 6 or 8 heads? I can imagine. But yeah, we see clearly the fish cans are filled in afterwards. Automatically. So one head, one eNod, one load cell. Mm-hmm. Okay. Good. Another example here with
yes, a bottle of oil.
Oil, yeah,
yes. Okay. So the bottle of oil.
So it's
in a rotative machine of dosing, filling machine. So you have for each head one weighing system.
One eNod again.
Yes. Okay. One load cell, one eNod.
Okay.
Okay.
So that's the forming of the bottles you see here. Then.
Yes. Yeah. In the pet manufacturing, just before generally, yes.
For the very typical.
Yes.
Typical functions.
With the main problem is cleaning, and of course, if you have a leak in the bottle, you have to detect also the system and stop filling when there is a hole in the
bottle. Of course.
In the bottle.
Otherwise, you waste some product. Yeah. So it's very high-speed applications.
Yes.
Most of us know.
And requires advanced adjustment and filtering. Yes,
yeah, of course. Yeah, I'm just checking if the video is okay on the display. That seems okay. Once again, as I said before, the oil is dosed by gravimetric because it's a quite viscose product.
It's just a little under pressure. Generally, the tank of oil is under pressure.
Yeah, okay. So
also
to make the speed.
Yes, and to have something constant with the valves. Okay, because
with milk or water, usually it's volumetric systems used, but here it's a very typical application.
It depends of the price, particularly.
Yeah, also, yeah, indeed. Okay, thank you. So that was about the applications themselves.
Yes.
So now we jump
we will speak on the use of our product in eNod4-D.
Okay, so this is the first page.
It's the first page that allows to connect to the product. And the first page of our load cell, you have different fields, as you can see here. So sorry. The first one is the selection of the communication port, okay, because you use a virtual COM port, USB interface generally. So you need to know this COM port, also the communication baud rate that you want to use and the address. But you have the possibility to scan the system. So automatically the COM port will be defined, affected. So if you search, you can see that the COM port will be refreshed. If you disconnect your plug and you search one more time, you will see that the COM port will disappear.
Okay.
So it avoids to search in the configuration panel the value of the COM port.
So you mean it's an automatic detection?
It's an automatic detection, but so there is a scroll of all the possible addresses at all the possible baud rates. Okay, and on all the possible communication ports. Okay, so generally it's better to fix the values that you know, because any standard product at SCAIME is at 9600 baud rate and address one by default. Okay. So it's easier to know. You have just to know what is a communication port.
So when you get it out of the box, it's 9600 bauds, address one.
Yes. Okay. Then when you start, so it's explained in this case, you can select. You're ready. It's not a problem, and you connect. You start the system.
Okay.
Automatically, all the settings of the product are entered in the firmware, in the software. So we can start with all the calibration and so on, all the parameters.
So now we are connected and we want to do the first calibration.
So as you can see, you have in the calibration the unit of weight that you have, the scale intervals that you can select,
so by 1 gram,
1, 10, 5, 10, 50, what is possible,
what you want. Okay.
The position of the decimal point and the maximum capacity. It is the maximum capacity of the product you want to use, not necessarily the load cell, because you can work on a partial range. Remember that by default, our products are factory calibrated, and we have 500 of 1000 dots. So you need to change this value to have something lower, because it will condition all the functioning, zeroing, tarring, and so on. So you need to have something real. If you have a tank of 1 ton, use 1 kg and for 1 ton. Okay.
You need to have the dead weight for the calibration.
Okay. And it's not the gross values that you have here. It's only the net value. If you have a tank, the dead load is not counted. It's just for the dimensioning of the load cells. Okay.
So in settings, you have this first page where you select the unit, the interval, as you said, and if you want to have some figures after the comma or decimals, and the max capacity. Okay.
But always remember that all the data that are sent to the PLC are integers. Unit is a change of the indication, but comma it's a field that is additional. It's not in the data. We don't send the real, we don't send the float value. We send an integer and you place a comma
where you want
at the setting of the decimal point.
Right.
Okay. Then, when you start the calibration, we are here in a physical calibration. So it's a learning cycle where we will get the value at 0, and then we put a standard mass or a known quantity of product in the hopper, and we perform a physical calibration by learning. Okay. As you can see, we can select a number of segments in the system. Yes. We can allow 1, 2, 3 segments. Generally, with a load cell, it's not necessary to use several segments. It's only when you are in non-linear application, so very, very poor design of a system because load cells are linear. So right. Only one point at 75% of the capacity is a good choice.
Okay.
Okay.
So the dead load you would select would be 75% of your max capacity that you showed us earlier.
Okay.
Okay.
So as it is shown here, if you put several segments, yeah. In fact, you increase the non-accuracy because you accumulate the errors. Yeah, so it's not a good choice.
It's better to stick to one segment.
Yes,
with one good load.
Okay. You have here the slope coefficient. When you have calibrated the system, it's individual values by segments that are used by the system.
So you don't enter anything here to
no,
calculate the coefficients.
It's just calculated
automatically.
Automatically.
All right.
Okay.
So we click on send and start the calibration.
Start the calibration. Okay. And then the system invites you to unload the system. You let only the dead load of the scale.
Okay.
You start. There is a zero acquisition. Okay. When it is done, it displays the internal number of dots of the system. Remember, we have 500,000 dots, okay, per 2 millivolt by volt.
So here is the 0, basically 92,400.
Yes, okay, for the system.
0 value, okay.
Okay, and then the system invites you to place the load that you have chosen before, okay, in this case 5 kg. You click OK, and then you have also the indication and the number of dots for these points, okay?
So this 173 is the 5 kg converted into points
for the system. Okay.
So and, now
and then the calibration is finished. So you click OK to leave this page.
Okay.
Okay. When you click on the Home tab of the menu, you come back and you can see the indication of way. As you can see, you have here the indication in the formats you have chosen. In this case, it was 5 kg. I don't remember what was the capacity in this case. And you have also the indication of the factory calibrated points.
0 points.
At 0, okay. It shows you if your system works or not.
Yeah, it's a cross-check.
Yes, of course.
Okay.
And you can check it before. Generally, if you put something on the scale, you can see that it is increasing, and you can also check if you have the intended value.
Yeah,
of course. If you have a problem with the wiring of the load cell, you can check it immediately, because remember, 5,000 of dots per 2 millivolt by volt of signal. So you know exactly the number of load cells, their sensitivity. You know exactly what is the intended signal that you have.
Yes.
Okay. Of course, you have the information on the device. Don't care of the serial number. All our modules have the same serial number in the firmware, because it is not updated. I think sometimes we will updates the serial number inside the module, but for the moment it's not done. Don't care of this value. You have the firmware version, the metrological version that allow certification for the system. And also some details on the configuration of your product. If you have an optional board for analog output, if in this case we are in CAN version, it is a standard one with an option of analog output. Okay. So we can go to the filter settings session.
The scale is calibrated, connected and calibrated.
Connected and calibrated.
And now we have to fine tune the filters.
The filter settings.
See what's happening on the dosing system.
Okay. Of course, sometimes you can invert filtering before calibration because sometimes if the environment is not stable, you need to
do the filtering
before, because perhaps you will not find an issue in the calibration if filtering is not enough. Okay. So filtering, we have on the first level, you have here the rejection of the supply mains, 50 Hertz or 60 Hertz, depending of the country where you are. In Europe, it's 50 Hertz. And then you have the AD conversion rate, knowing that higher will be the AD conversion rate, higher will be the noise for the system, because it's a delta sigma converter. So you need to adapt the AD converter rate to your application. For dosing system, for very slow rate system feeding, you can use 100 conversion by second. For high-speed system, I will recommend something like 200 to 400 measures per second. Yes, to be more rapid and on the action of the system, because all the internal cycle of our module is cadenced by the AD converter rate.
So it's a very important first parameter to see.
Yes, okay. Yes, okay. Then you have the low pass filter. This is generally the filter that is used quite systematically in dosing, that you can activate or not. In this case, it is activated. You have the order of the filter. Generally, we use an order 2 that is sufficient. The increase of order only allows the rejection of higher frequencies. It does not change the response time of the system. Okay, the response time is the same. It only changes the rejection of higher frequency.
The higher, the stronger.
Right? Yes. Okay. You have here the cutoff frequency that you can input in the system, which is the cutoff frequency of your system. Okay. For the two other frequency, it is used for advanced application when you are in a very fast rate system, allowing you to unconnect and change the filtering during different phases of dosing. I don't know if it's clear. It's quite complicated, so but
if you can adapt the filtering during the dosing, you have different phases.
Yes,
and you can change the filtering during
automatically. And especially when you unload the system, because dosing system require quite strong filtering, and when you unload, you have the response time when you unload. If filtering is at higher frequency, the response time will be lower, and so you will win some time when you unload the system.
Dosing speed.
Okay. Notch filter generally not used in dosing, much more used for check wire or something like that, because it is a bandpass filter that allow to eliminate some high-speed frequencies. Okay.
It's just to cut
some vibrations.
vibrations
Yes, okay. In dosing, generally, not used. You have here the setting for the average flow rate, okay, for the systems that allow you to have some control on the dosing system, knowing if a valve is not operating properly, if you have something wrong, you can detect with the average flow rate the information.
So if this average is changing, that it could be that the valve is going crazy or something like that?
You can have something that is not okay. It can be blocked.
A sticky product?
Yes, something can be blocked, and the flow rate is not intended, so you need to have an intervention of an operator. Okay. And you can detect it. Never use the self-adaptive system, which is much more used for static applications.
Yeah.
But for dosing, never use.
For dosing, it's not recommended.
Yes.
Okay.
Yes.
Okay.
Okay. So what is new actually in your product is new features to adapt filtering depending of the zone. It's only for very high-speed system.
Okay. So
where the cadence is very high.
So this is what we are saying here. For 95% of the applications, the filters we are showing here are well adapted to the application.
Yes. Okay.
Okay.
So you have the values that are offered from 6.25 to up to 1060. Never use, never use, because it's too much noisy for the system. Okay.
Yeah, you can go up to this, but we don't recommend.
Yes. Okay. And about the low pass, we use a Bessel filter with different orders, and we recommend the order 2. That is sufficient because it's a digital filter. So if you use very high order, you will have a very small coefficient. And it needs a lot of computation internally in the eNod4.
Using some CPU
yes, it's better to use an order 2. Generally, it's sufficient in 85% of the applications. Okay. So now we have
calibration, filtering. His phase is done.
Okay.
And now we need to go to the deeper in the application.
Yes. Okay. It's much more
fine-tune the system.
Yes. Okay. Because you define how your cycle and how it works.
Okay.
Okay. First of all, in the general menu that you have selected here in the settings, you choose the operating mode. You can choose the filling mode or the unloading mode or a transmitter mode, but if you want to dose, it's generally a filling that you use. Okay. In this application, sorry. Yes.
Yes.
So
here you are in the
filling. In the application tab that you have here, okay, I was in the general. And I'm in the filling mode. So you have all the window, and there is here you can directly simulate the application for dosing directly from the software, because you can start a cycle directly from it if the wiring is according to your application, because eNod drives the valve in the application. eNod checks, pilots directly the valves in this application. Okay. Okay. So we have, I don't know if I don't remember if it is. Yes, we have the different sections.
So this is the global tab.
Yes. Okay.
And then we focus on each section of the tab.
Okay. So the first section concerns the set points, the target and associated tolerance, and empty weight, which is a starting condition for the applicative. Okay. So you have the target weight here.
So 1 kilogram.
In this case.
1,000 grams. Okay.
The tolerance that is applied to the target obtained after dosing.
Okay.
That can be within this tolerance or outside. Okay. You have the possibility, if you are in a tolerance negative, to re-emptying the system, to refill a little bit after
close to the target,
after result determination.
Okay.
And here you have two values, which are mean empty weight and max empty weight, which are conditions for starting a cycle. It's very important to fix these values.
Okay.
If values are 0, there is no control for starting. So when you initiate dosing, you can put 0 for the beginning, because there is you avoid any blocking
Condition.
situation. Okay.
So this would be for the first.
Yes, of course, because
test, let's say.
Start conditions are necessary because you check if your container is in place or not.
Exactly.
Okay, for the applicative.
Okay.
Okay. Then you have the management of the in-flight, as you can see. We have it in the second part.
Yes.
It's the in-flight management. And we have two things possible. The automatic correction, that you decide to activate or not.
Yes.
eNod is able to correct automatically the in-flight depending of the result of dosing.
Of the previous dosing.
Okay. So for the next dosing, he will determine an in-flight depending of the rules you have applied for your system.
Okay.
Okay. You can use a table or not for the correction table, because the in-flight can be limited to a minimum value and a maximum value in your application. Okay. And also, this in-flight cannot be higher than the threshold from coarse feed to fine feed in general.
So here, just to be sure, we are in grams or in the unit.
In the unit you have classed.
Selected.
All the data are in the same unit.
This is why it's important to do it correctly in the calibration phase. Okay.
The correction tab is also interesting because it allows to correct differently if you are far or close to the target you intend to dose.
Yep.
Okay. If you are far, it's very interesting to correct a lot the in-flight. And if you are close, it's not necessary to correct at all. Yep. Okay. So you can adjust within this table, depending of the error you have obtained, a correction that you can apply here in percent.
That's in percent.
That's in percent is in this application. You correct 100% of the error, or 50% of the error, or 10% of the error when you are close to the system. Okay.
Okay.
There is also the ability to triple the correction if you are out of the tolerances for the system, to correct strongly and efficiently in a number of batches lower. Okay. Okay. I think it's all for the in-flight. Then we have the cycles that I show you in the system. You have all the cycles that are defined here. Okay. So you have a delay at the beginning. It's really a delay that allow you to let the system getting in place. Okay. Because just below you have the TAR that can be possible in the cycle, and the TAR and also the result determination is defined by a time which is the motion timeout in our application. So you define here a time for the TAR. Remember that if you have a 100 measure by second, if you put 100 milliseconds, you will have only 10 measures for TAR determination and need them for the result. So 100 is a very minimum value. Generally, we use 200 milliseconds. That is the time that is required for the system. Okay. Then you have different neutralization time. Neutralization times are time at the beginning, when you start the coarse feed, when you start the fine feed, and so on. There can be an effect of the system, the dosing system, and so you can do nothing. You can control nothing. You can do nothing. You cannot. You are not able to calculate the flow rate at this time. So neutralization times are it's written delay, but it's not a delay. It's a neutralization. Okay, I think this term will be changed very soon. Okay, donc it's a period where we do nothing.
Nothing is happening.
Okay. And then the final stabilization time, it's quite a very important value because it defines when you have finished dosing, it's the time to let establish and let stabilize the data. So in the second time, you have the result determination that is done to get the result.
Yeah.
If the final stabilization time is shorter, you will have a wrong result in your application because you will determine a result in a non-stabilized period
of time.
Okay.
Okay.
And there is the last delay, which is the end of cycle delay.
Okay.
Okay, that allow at the end when the result is defined, when the system is unloaded, you have some temporization, possible temporization. Of course,
before the next time,
nothing is fixed. Everything can be set manually. So it's only when you simulate the applications that you can adjust those
timeouts. Okay.
Okay.
Okay. Makes sense.
Very important information. It concerns cycle options, emptying or not emptying. Some systems have not any command of emptying. It's only if you empty an hopper for do the ejection, and you need to emptying the system at the end.
It's not compulsory.
Okay. Yes, you can adjust or not this application.
Okay.
A dynamic dosing. Dynamic dosing differs from classical one. Classical one is done on stability criteria, which is defined by weight. Dynamic dosing is a feature that allow you to compute all the measures during the motion timeout, measuring time, if you prefer, and check also the standard deviation of all the measures. So it's a dynamic mode that we can check the quality of the time, the quality of the result determination.
Of the cycle, basically.
Okay, because the static one, it's a criteria. And for an automatism criteria, it's not the same period because if you don't reach the criteria, you will take a none-of-the-fly value, and it's not a good idea at all.
Definitely.
Okay. You have for the cycle the ability to automatically start. Okay, when there is a detection of the container, automatically the cycle can start.
So with an optical detector or something like that, or
no, by weight, exclusively by weight.
Exclusively by weight. Okay.
You have the ability to restart, to refill the product if you are out of tolerance, minus, of course, because if you are out in plus, it's not possible.
Take the product out.
Yes.
So that means the eNod will restart for a very short time to fill the little.
The form film a little bit if it is lower.
Okay.
Just to get the target.
Or deactivate that.
Yes, it's optional.
Okay.
Also, the ability to recovery cycle. If you are starting a dosing, you interrupt the dosing, you can complete it, and you can decide or not to authorize cycle recovery.
Okay.
And of course, a very important thing, the TAR at cycle start. Okay. Something is missing because in the new version we have also a 0 at the end of cycle that is missing in this
in the new
in the display. So sorry. So sorry. You have here the flow selection. You can select plenty modes possible. You can use classically coarse feed followed by fine feed, but you can also have the coarse feed and fine feed, and then the fine feed. You can also select several ways: fine feed, coarse feed, followed by fine feed when you are in liquids and so on. So plenty choices.
This can be selected in the tick box.
Yes,
we see here. Okay. So
yes,
it's presets.
It's preset for the system.
For the system.
You have a choice that is allowed.
All right.
Okay. Where you are in coarse feed and fine feed, you have the form feed threshold value. It is a relative value to the target.
Yeah, so
okay, it's not an absolute value. When you will reach something 500 close to the target, the fine feed will be active. Yeah. Okay.
So we start from 1000 and we withdraw the 500.
But it depends if you are loading or unloading. When you start to zero, that's right. You have a target of, for example, 2 kg, the fine feed will be activated at 1500. Okay, in this example. Okay. The high feed, it's when you have the high feed cycle activated. Necessarily, you need to have 2 thresholds, one for the high feed and one for the coarse feed to fine feed. Okay.
Okay. So same.
We have the same thing. It's always relative to the target.
Exactly. Okay.
Okay.
Fine.
The analog output. It's a new feature that we introduce in our product, and you will see that we have used it for our small video. It's systems that allow to pilot the coarse field or the fine feed directly by the analog output of the board. So you define a level, and fine feed and coarse feed are directly activated. You can see that we have 80% of the analog output for the coarse feed and 40% for the fine feed.
Yeah.
Okay. With the ability to have some runtime to protect a little bit the system.
The system, so there's no shocks. Or...
Yes.
Okay.
Okay. You have the average flow rate for the system calculation with the meaning on the system up to 128, and also a decimation factor. Decimation factor allow you to pick 1 per 100 measure or 1 per 200 measures for determining the flow rate, the loss of weight or the change of weight.
The sampling.
Yes.
Sampling through the process.
Yes. Okay. Yes. And also the flow control that can be used to detect a leakage in the container. Okay, because you have the mean variation in coarse feed, the mean variation of weight in fine feed. You can detect depending of the flow rate that has been calculated. It's why when we are in neutralization period, the flow rate is not calculated. There is no control.
There's nothing happening.
Okay. And the time interval that you check and the stabilization used for the control. Okay. So it's quite complex, but the initial control of flow rates that we have decided to put in our product was not functioning, and it's why we have put something much more sophisticated for the control.
Well, it's true to say what you say. You need some learning time to know how to fill all these fields, but also true, once you are accustomed with this, you can also reload the same configuration to your next. So you don't do for each system. If your systems are rather similar, you can reload the same parameters from a configuration you save in eNod view to your PC, and from your PC to the next scale, basically.
And the last parameter that is very important for especially current product we manufacture. It's the emptying threshold. This value can take different, depending of the value you put in the setting, you will have different behaviors of your system. If the emptying settings is put to 0, knowing that you can have no emptying cycle, okay, but the emptying parameter is always used. And if it is null, the dosing result is determined. When the dosing result is determined, the cycle is finished. You have just a delay after only, and the cycle is finished. Okay. Even if there is no unloading. Okay. It is the case when the emptying setting is 0. Okay. When you have a positive value, the cycle will be finished when the indication of weight will be under this threshold after weight determination, weighing result determination. Okay. So you have the cycle, coarse fit, fine fit, stabilization time, you determine the result, and then you wait the weight to be under the emptying threshold.
So if it's 10,
okay, so it's the second way of the system. And the third way is when the emptying setting is negative. So in this case, there will never be an end of cycle, because it is required to send a command or activate an input to tell to the eNod that the cycle is finished. Okay. Especially for automatic system and rotary filling machines, where the system knows exactly when the container is in place and so on. So it starts, because this function, this threshold is used to unselect and select filterings. Okay, so if it is not used properly, the result can be a disaster.
Exactly.
Okay. So it's all for all these parameters.
Okay. Right. Thanks. Thanks, Bernard. So as I mentioned earlier, we have now a 10 minutes video where you will see all these parameters implemented into the eNod view. And with some, we wanted to show you some live things. So of course we have prepared this video so that it's in 10 minutes time. And then we meet again in 10 minutes to your questions and our replies. So thank you for your attention and enjoy the video.
We can connect to the module. If you know the communication port number, the baud rate, and the address, you can use the automatic searching if you want, if you don't know it. I connect the module. Now all the settings are loaded in the software. You have immediately the weight that is displayed on the right of the screen. If I pull out the container, you will have the indication at no load. Now I will proceed to the calibration. My scale is fitted with 3 bending beam load cells of 10 kg, and I choose to use 1/3 of the capacity and use 10 kg, unit of weight grams, scale interval 1, and decimal point without. So I start a physical calibration with 1 segment, only 1 point. You can choose 2 or 3. You choose the value, which is 5 kg in my application. I'm invited to unload the system and to validate, then to place the 5 kg standard weight on the scale and to validate. Okay, the calibration is finished. you can see the slope coefficient on the right of the system. And the indication of weight is 5,000. If I pull out, it will be 0. And if I put a 1 kg mass, you have 1,000 on the display. All is okay. Now I'm ready to put my container and start the filtering sections. It's possible to choose a rejection of 50 or 60 Hz, an AD conversion rate, I've chosen 100. I choose also to activate the low-pass filter with an order 2 and a cutoff frequency of 3 Hz. The other cutoff frequency are for advanced application, not filter, not used, and average flow rate, it's a coefficient that you can use for the flow rate determination. On the mode, I choose filling mode. You can also choose dosing by unloading. Now I'm ready to go on the application tab, and so you have all the settings. The first one is the target value, which is 500 in my application, tolerances, minus, maximum value, and min and max empty weight, which are conditions for starting a dosing cycle or not. If I put a lower value for the max value under the weight of my container, now it's not possible to start a cycle. So now it's not more possible to start a cycle. So I will change the value to 500 to allow a start cycle condition. Concerning the in-flight, you have the choice to propose an automatic correction or not in the system. You have the minimum and the maximum value for the in-flight value. You can choose the in-flight value too. And also, you have the possibility to use a correction table. So, the correction table allows to correct the in-flight differently depending of the value to correct. If you are far of the target, the correction will be important. If you are close to the target, the correction will be lower. About delays, we have the first delay, which is a starting delay. Then you have the time that will be used for TAR and result determination, which is the same time. Neutralization times for coarse feed, fine feed, and so on. And also stabilization time now, just before the result. And then an end of cycle delay at the end of the system. What is very important is a threshold to stop emptying. If this value is 0, the cycle will finish when the result is given. If it is positive, the cycle will be finished when you will be under the value of this emptying threshold. Of course, there will be the end of cycle just after. If the value is negative, the cycle is only finished when there is a command or an input. About the cycle, you have an automatic start, possibility to include cycle option, emptying, automatic start, restart the fine feed if you are out of tolerance, cycle recovery authorization, I've chosen the tar at cycle start and no zero at end of cycle. Of course, you have also the selection for the coarse feed, fine feed, for the functioning of the dosing system, and also the possibility to choose a threshold which would be depending of a percent of the target. So if you change the target, you have an automatic value for the threshold. So it can be done automatically without changing the fine feed threshold manually each time you change the target. My system uses analog output driving for coarse feed and fine feed. So you have 80% for the coarse feed and 40% for the fine feed, because it is a vibrating system driven by the analog output of my eNod4 board. I'm now ready to start a cycle. So the coarse feed starts. And then the fine feed. Okay, you have the result that is displayed. The cycle time, the coarse time, the fine feed time, and statistics are also updated. I will empty my container to allow a new cycle, because it's not possible to start a cycle when the weight is outside starting conditions. I put my container and I can start a new cycle. Coarse feed, and then fine feed. Result is -1 when the cycle is running, and then you have the value of the last result.
Hello, welcome back. We hope you have enjoyed that short video, rather short video. Yesterday in the training was much longer for the eNod4-D. So I will share my screen again and finish on the points to be remembered, the conclusion of this training. So coming back on the eNod, so you have understand it's eNod4-D stands for dosing, so it is meant for filling, batching application by filling or unloading, depending on which hopper you weigh. You have one only programming environment, which is the eNod2 software, which Bernard has mostly presented to you this morning on this quick start guide. It's a user-ready, we have user-ready HMI, which are called eNod Touch MS. So MS stands for multiple eNod small screen, and ML, multiple eNod large screen. And these are with preloaded firmware. So when you connect your eNod4-D to the eNod Touch, it will automatically recognize it's an eNod4-D, and you will have all the features or all the parameters you see in the eNod View 2 from directly accessible from the HMI. Of course, eNod4 is compatible, eNod4-D in this case, compatible with all load cells from SCAIME, but also from any other load cells from the market, basically, because the sensitivity of eNod4 is very wide range. So if you have to retrofit an existing application and you don't want, or your client doesn't want to change the load cells, you can implement eNod4 without having to use the SCAIME load cells, basically. eNod4 is compatible with 95% of the industrial PLCs from the market and 95% of the commonly used field buses and protocols. So to finish, it's a very flexible platform programming software, so flexible solution and also very price competitive compared to the backplane module that you plug on the Siemens. So some of you may know about the Zivarex, for example, from Siemens. So it's much more competitive offer with eNod4 if you select eNod4. And of course, if you need any price, I will be there or my colleagues. So your local sales rep or distributor can give you the pricing for the eNod4-D, the prices for the eNod4-D. We are now almost at the end of our session. So we have had a couple of questions. Thank you for participating. We have the first one is about the possibility to access. So is it possible to access to the eNod Ethercat through the web server? So Bernard is a specialist, so he should try to answer that one.
Yes. The answer is simple. We have no IP address in Ethercat because IP address is known by the PLC, and we, except by a ping, you are not able to access to the IP address and the network characteristics. So yes, it's possible to access the web server. The web server is programmed in our product, but you can access only when you are disconnected of the PLC, you know the IP address, and also through the PLC, but not on the network because you don't know the IP address. Okay, I don't know if the answer is clear, but it's not so simple in
so you need
Ethercat.
In Ethercat, you need to go through the master of
yes.
of the bus. Okay.
Yes.
Okay.
Yes, because there is no Ethercat is no does not support TCP/IP protocol. Okay. So it's why it's quite different from other protocols.
All right. Okay, I understand that.
Okay.
Okay. The next question. One of our attendees would like to go back on the typical filtering parameters that you would recommend. So we were a bit fast on that one. So the idea is, what would be your suggestion or recommendation for covering 90 or 95% of the other slow dosing applications?
Okay. Small dosing systems will be 100 measures by second and filter order 2 with 2-3 Hertz cutoff frequency. For high-speed system, I will recommend 400 conversions by second and a filter between 1 Hertz to 2 Hertz for the cutoff frequency in order 2.
Order 2?
Order 2.
Okay.
Yes, it's main settings that we can recommend.
Okay, so that covers a lot of applications.
Yes.
Okay, good. Third question through the chat was if the eNod2 software would also work on a Mac, on an Apple computer. Something we know? It works in it's a Windows-based.
It's C# development.
Should work.
I don't know.
We'll get back on that.
It's a good question.
It's a good question.
It's a good question. The firmware works on the framework Windows, framework 4, if I remember. So there is no framework in Apple systems. So
okay, we'll get back to.
Yes.
Thank you for that nice question. We'll get back to you on that one because we are not quite sure ourselves. So we'll have to check with our R&D.
It's a Windows environment.
Yeah, it's a Windows development at least. Okay, thanks for the question. Next question is, can the PLC also monitor the valves directly? I think you've shown that the eNod4 is able to monitor the valves, but can also the PLC do that behind the eNod, I would say?
The eNod propose to pilot directly the outputs,
yes,
and for cleaning to pilot these valves for cleaning. It's the first way. The second way is to use analog output for valves.
yeah.
And the last one is to program the output for the valves and pilot through the PLC,
Okay.
because you can, in implicit messagery between the PLC and the eNod, you have the data of the input and the output. So you have all the data of the cycle available and also all the data on the output. So PLC can manage. Problem is the delay. Generally, with Profinet or even Ethernet IP, we have a response time of some milliseconds for the delay of command. For sure. High-speed rotative filling machine, 1 millisecond is 1 gram.
Yeah.
So if you spend 10 milliseconds for the reaction, you will spend 10 grams.
10 grams of
accuracy.
Okay.
Okay.
So we recommend basically to, when possible, to use the IOs of eNod4
for high-speed system. For low speed,
the PLC
doesn't matter.
Doesn't really matter. Okay, interesting. Thank you. So coming back to the question about the Apple, is eNod compatible with Apple? We also have a second question is about Windows 10. So for Windows 10, as far as I know, is okay, because
yes.
I am myself using Windows 10, so it works on Windows 10.
It works perfectly on Windows 10.
The last question so far is about the IP configuration of. So when we have an eNod4 Ethernet, can we do a new IP configuration through the web server? Is this something possible?
It's not possible to configure the IP address, gateway, and network mask through the web server. Okay. Because it's impossible to write in our gateway.
Okay.
So unfortunately, we can have some new features. It's possible to save the configuration of an eNod through the web server and reload this configuration if required. So it can be interesting for after sales, because it's very easier to exchange a module and reload the configuration, and immediately the product is operational.
Okay.
Calibrating parameters included.
Yeah. So not about the IP configuration, but the application parameters can be reloaded through the web server.
Totally, and calibration and
of course
and so on.
Okay, so that's very convenient. Right. That's about it for the question and replies. If we are now finished with the questions, we'll be very happy to thank you for this, for your participation first. Quite a lot of questions, thank you, and for your attention, most of it. It's a rather new exercise for us, so we hope you enjoyed it. And we don't shake hands because we don't have the right to, but we say bye-bye, and we hope you keep safe and well for the next session, which you can of course attend for the coming days. Thank you, everybody. See you later.
Bye.
Bye-bye.